Today's show is sponsored by Cloud Academy. Listen up, y'all. This is a great offer. With everyone using the same cloud platforms, winning and losing comes down to having the best talent to build products better and faster. Cloud Academy is the training platform of choice for Fortune 500 companies and thousands of tech professionals around the world. Thousands of video courses, learning paths, practical hands-on labs in real-world cloud environments, Cloud Academy has tools designed to help teams assess, build, and validate critical cloud skills. Most importantly, Cloud Academy stays agile, challenging you with new content, labs, and tons of features that ensure your skills stay relevant and everyone can level up. They cover everything from cloud certifications to DevOps to security to programming languages. You can get started now at cloudacademy.com. For a limited time, Cloudcast listeners can lock in 50% off the monthly price for life. Just put in the coupon code CLOUDCAST at checkout. It's a great way to pursue certifications or just build cloud expertise. Again, that's cloudacademy.com and use the coupon code CLOUDCAST to lock in 50% off the monthly price.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well as we continue to fall into October. We continue to move through October. The month seems to be moving very, very quickly, and obviously lots going on in the world, elections and other things like that. As always, as we've been doing for the last 6+ months, hope everybody is staying healthy. Hope everybody is staying safe, protecting your friends, protecting your families, trying to do the right thing and see if we can get this virus under control, but hopefully everybody's doing well. Lots of news this week for Cloud News of the Week, so let's jump right into that. Kind of an all-over-the-place Cloud News of the Week. A little bit of announcements, a little bit of some launches, some different things, so let's jump into it. First thing that we caught that was sort of interesting was MongoDB, former sponsor of the show, good friend of the show. MongoDB Atlas has announced that it's now going multi-cloud. So it's now offering some new clustering capabilities that allow it to span multiple clouds. We thought this was interesting, number one, because MongoDB Atlas is doing extremely well from a SaaS perspective, really helping to kind of reshape what Mongo looks like. But we thought it was also very interesting because it continues this trend that we're beginning to see this year, where we're seeing data services, namely GCP, BigQuery, Omni. We've seen this with Snowflake. We're now seeing it with MongoDB Atlas. The ability to span a service across multiple cloud providers. Really interesting, really brings up some interesting resiliency perspectives, offers the cloud provider or the cloud service some interesting relationships and leverage with the cloud provider. So it's going to be an interesting trend to watch, something we're probably going to want to dig into a little bit more. But that's an interesting next sort of bullet point in this new transition we're seeing around spanned data services, if you will. The second one is that Atlassian announced that they are transitioning to cloud-only products. So Atlassian, really well known for their developer tools, their project management tools, and so forth. And this, again, continues a trend that we just beginning to see with companies like Snowflake. We've seen it with Datadog, longtime sponsor. We've seen it with a number of kind of SaaS companies, but you don't always see it necessarily with, kind of enterprise companies. And this is interesting because Atlassian has for a long time sold both a SaaS offering and an on-premise offering. And they lay out kind of a transition plan over the next couple of years to move towards cloud only. So we're seeing more and more companies being able to build a business case and a technology set, and most importantly, a set of customers who are accepting, especially in the enterprise, which is tough, of cloud-only offerings. So this is definitely a trend we're going to be wanting to watch in 2020 to see how many more offerings we see like this. Obviously, SaaS has been this way for a long time, but seeing if this transition continues. The third thing on our list was HashiCorp, longtime friends of the show, announced a couple of new offerings. One was called Boundary, which is really a kind of authentication service, a way to have a single point of authentication to, federate across a lot of different offerings. And they also announced something called Waypoint, which is, Waypoint, not Wayport. And this is kind of somewhere between sort of like a Cloud Foundry PaaS type of offering and sort of like a Chef Habitat sort of package management type of offering. The folks over at Software Defined Talk, Matt Ray and Brandon, did a really good job kind of walking through this as a first stab. We may have to have the folks from HashiCorp come on and kind of give us some explanations, but new service offered from them, and they continue to offer things as cloud services. They're now offering Atlas as a cloud service, so kind of a big week for HashiCorp. Their HashiConf was this week. And then finally, to wrap up Cloud News of the Week, want to give a big congratulations to one of my old bosses, longtime friend of the show, Jeremy Burton, and the folks over at Observe have launched a new observability platform. We are seeing more and more companies begin to kind of move from things like monitoring into observability. We saw Splunk made an announcement this week about integrating the SignalFX technologies. But congratulations to Observe. Again, a longtime friend of the show, Jeremy Burton, is their CEO, a friend of the, has been my boss before. So I'm excited to see sort of what's happening in the observability space between Datadog and between Honeycomb, now Observe, and many others is really starting to heat up. So definitely something we will want to be digging into more and more in 2021 as well. So with that, we're going to wrap up Cloud News of the Week. Very full week, lots of announcements, lots of interesting trends. And we're going to dive into something we've never really talked about. After the break, we're going to dive a little bit into what's called confidential computing. So excited to talk to some very smart folks with that right after the break. Today's show is sponsored by Datadog, a cloud-scale monitoring platform that unifies metrics, logs, and traces from technologies like Istio, AppMesh, and Envoy. Plus, Datadog's Service Map automatically plots out the dependencies in your microservices architectures for seamless, context-rich troubleshooting. With rich visualizations, algorithmic alerting, and more than 250 vendor-supported integrations, Datadog allows you to monitor your distributed applications in real time. Start a free 14-day trial today by visiting datadog.com/cloudcast, and Datadog will send you a great free t-shirt. That's datadog.com/cloudcast. Today's show is sponsored by BMC, and BMC wants to know, is your business on its A game? The A game is when systems are intelligent by learning from markets, where automation is paramount yet effortless, and when technology and people work as one in an enterprise. The A game is your business at its absolute best. BMC calls this the autonomous digital enterprise. Find out more at bmc.com/agame. That's bmc.com/agame. And we're back. And, folks, one of the topics that obviously comes up all the time and comes up in so many different ways is just around security. And obviously more and more we are using cloud computing. We are putting our resources in the cloud, our applications in the cloud, our data into the cloud. We're interacting with a lot of different services, across the world. And, there's a change that happens in terms of when you move from being on premises into the public cloud of not only, what is the service I'm using, but how's it operated? How do I know that my data is encrypted? How do I know who may have access to what's going on? And that's a whole space that we've dug into a little bit over time, but we've never really dug into it. It's an area that's now being called confidential computing. And so we thought we'd go off and get the experts on this to come talk to us about it. And so we're really excited today to have two excellent guests, both Vikas Bhatia, who is head of product in the Azure Confidential Computing group at Microsoft, and Ron Perez, who is an Intel fellow in the Security Architecture Data Platforms group. So Vikas and Ron, welcome to the show. Great to have you on.
It's great to be here, Brian.
Yeah, thank you. Great to be here.
Yeah. So before we dive into this, let me do two things. One, I want to get a little bit of both of your backgrounds because I know you've both been in this space around, how to make sure that we keep our information safe. But I also want to kind of give the listeners a chance to connect one voice with the other. So, Ron, why don't you go first? Give us a little bit of your background and kind of the areas that you've been focusing on at Intel.
Sure. Well, you already touched on that. I'm an Intel fellow in the data platforms part of Intel. So obviously focused on a lot on cloud computing, and my focus area is security and specifically architecture and what we call pathfinding. So really kind of determining what the next challenges are in the security space, right? And what kind of technologies and solutions are going to be needed to address those challenges. But beyond that, I have over 30 years of experience in the business, the vast majority of which has been in security, but all the way from silicon, like what I'm doing here at Intel, all the way up the stack up to the application layer, right? And how to link hardware and software together and do wonderful things with security.
Excellent. And Vikas, give us a sense of the scope of what you've been working on at Microsoft and at Azure and bringing confidential computing to the marketplace.
Thanks, Brian. Yes, I've been at Microsoft now for 13 years, and I'm working on Azure Confidential Computing, as you mentioned, as the head of product right now. And it's really awesome to get a chance on working something that is so game-changing and something that Intel and Microsoft have been pioneering for the past few years. Outside of that, I've been in Microsoft, as I said, for 13 years, and I've done stints in I used to own the C++ compiler back in the day. I used to work on Xbox One. I did game streaming. I worked on the Windows developer platform. Microsoft is a great place because you get to try new things all the time. And so this is my stint in Azure, and I'm absolutely loving the time here.
Yeah, no, that's great. And it's great to have both of you on. We've got two very big brains, and we're going to dig into a topic that's technically fairly complicated, but very, very important to folks. Ron, I want to start with you. Defense in depth is sort of, kind of de rigueur. It's the norm in security. It's kind of what everybody expects. There's never one silver bullet. And we've seen, in the past, we've seen sort of this combination of, hardware level functionality that gets integrated either at the application level or the OS to tie those two things together so we know and we can trust, what we're running on, where we're running. I know back in my day, I used to work on something called Intel TXT, right? Sort of early efforts around this. Where have we seen this space evolve? How have we, what sort of evolved from maybe 5-6 years ago to where we are today with today's sort of confidential computing capabilities?
Yeah, I think we are seeing a bit of it's not too extreme to say, a paradigm shift, right, with confidential computing. You mentioned TXT or trust extension technologies, right? That Intel trust execution technologies that Intel and others have pioneered in the past, right? Those have been focused more on how do we actually, say something with high assurance about the platform, right? Ideally, right, you want to say that the platform is secure. So you want to measure everything, right? Take a hash of all the different components in the platform and provide a trusted kind of quote or statement, right, to a remote party to say, this is the state of the platform. This is all the software that's running. This is how it's configured. This is everything that it is today, right? And then you leave it up to the remote party to determine, is that okay or not, right? Can I trust that remote machine? So it's all about, how you protect that platform and how you articulate to the rest of the world the state of that platform. Whereas confidential computing kind of takes this big leap to say, maybe we don't really care too much about the entire state of a platform, of a computing platform. What we want to do now is find a way to protect just the most sensitive data and code, even, right, the workloads themselves, right, that are running on the platform, and even protect that code and data from the rest of the platform itself, right? So there might be malicious software on the platform. There might be a malicious administrator on the, who controls the platform. Even in the face of those challenges, the workload and the data should be protected. And I think that's what the major goal of confidential computing is. That's what makes it such a challenge too.
Right. Yeah, and Vikas, obviously, operating Azure, customers have to trust that their environments are going to be somewhat isolated, and they've got to go through different things in which they may have to audit their environments. How do you have to think about that from the cloud provider perspective in terms of not only the technology, but just how you communicate this new world to your customers so they can feel comfortable about what's there, who's seeing it, who doesn't see it? How do you think about it from a cloud provider's perspective?
It's a really good question. So from the Azure perspective, we spend over $1 billion a year on cybersecurity and making sure we're providing the most trusted platform to our customers today, right? We certainly spend a lot of time in making sure that we hire the most trusted administrators. Our software is goes through the security development lifecycle. We have a strong set of processes that we have in place to make sure that the customers' trust that they put in Azure is something that we take very seriously. Now, at the same time, it's important to kind of step back and look at the customer motivations for what they're looking for when they are operating their most privacy and security sensitive workloads in the cloud. What we've seen is customers are increasingly looking for ways to trust as little as possible, right? And what this translates to is customers want full control over their data lifecycle. They want to prevent unauthorized access. That just doesn't mean access from the cloud provider, but also their own administrators, right? We've seen a few instances that have happened where a rogue administrator or somebody who got phished, right, was able to walk away with a bunch of sensitive information that these customers want to just make sure doesn't happen to their workloads. There are regulations and compliance issues that our customers need to think about when they migrate to the cloud. And also, I think another use case that confidential computing really solves is this untrusted collaboration where customers want to collaborate with each other but without sharing their data with each other. They want to get the business outcome, but they don't want to actually share the data with each other. And also in many cases, they want to make sure that their workloads are sensitive and protected in the cloud when they're running in a sense where, they don't want anybody else to have access to their workload, whether that is a government entity or whether that is, any sort of entity who may want to have access to their workload. They just want to make sure that they have full control over their data lifecycle. And today, what we do as an industry, we've done a great job of protecting data at rest and data in transit. But when we operate on the data itself, it happens entirely in the clear, right? So when your web service, as an example, is getting some data from, say, a database, the database is going to make sure that the data is encrypted at rest. But when it is in memory, when your web service is actually operating on that data in memory, it is entirely in the clear. So what could happen is there might be a bug in any of the stack that you're operating on, whether that's the guest operating system, hypervisor, and so on. What we can do with confidential computing is we can encrypt that data when it is being used. So only your code has access to the data and nobody else outside that trust boundary, whether that is your own guest admin, whether that's the guest OS, whether that's the hypervisor, or even our own cloud provider admins will not have access to the data. And confidential computing is, as Ron mentioned, a paradigm shift in how we see computing evolve, where this sort of capability essentially becomes ubiquitous over time.
Yeah. I think as we think about sort of, maybe the last decade or so of people using the public cloud, there was an early time when there was concerns of, maybe it's not that secure. It's, we didn't secure it as the end customer. We're not sure what they do. I think the mindset has sort of shifted that the public cloud is in many cases more secure just because it's consistently locked down. It's got known things. But we still have this paradigm of kind of shared responsibilities within the public cloud of, what the cloud provider does versus what the customer has to do. Vikas, walk me through a little bit sort of, as we talk about confidential computing, what are the elements, kind of the technology elements, the software elements that start to make up it becoming, confidential as opposed to, what used to be just, shared? You do this, we do this.
That's a very good question. So, the way I kind of like to explain this is, let's think about building blocks, right? A building block is a really simple concept that we can kind of just add on to, right? I think from a building block perspective, it's important to understand what a concept of a trusted execution environment is, right? We call it the TEE, right? The trusted execution environment, which says, I trust whatever is in this environment. And what we have today, running on Intel SGX, which stands for Secure Guard Extensions, hardware in the cloud, is we have a concept of an enclave. An enclave is a TEE, a trusted execution environment, inside which you can run your code and the data, right? So now you have a box, for lack of a better word, a box and an enclave that you're going to run your most sensitive data and your most sensitive workload. But just doing that, you need to first trust, hey, are you actually, do you trust what you're running, right? So what we have provided is an ability, for example, for you to, attest that the code that you're running is actually the code that you think you're running, right? So the customers can now, run against an attestation service, which gives them that quote that I know exactly what code is running in that enclave. Nobody has tampered with that code that I'm running. The data is completely secure, is running inside their enclave. So that first level of building block is understanding what an enclave is. The second building block is understanding what the attestation means to my code running inside the enclave. And the third building block is essentially the keys that I'm going to use to access that enclave. Right. So the keys themselves also have to be protected because you want to make sure that only you have access to the keys that are running sort of, on that code and data in that enclave. So when you put these three sort of building blocks together, what you have now is a trusted execution environment that you have complete control over. Nobody else outside that box has the ability to peek inside that box, inside that enclave, to really see what's going on.
Gotcha. So you're creating these sort of, like you said, sort of virtual private boxes, within obviously a big shared environment like Azure. Ron, what then, has to happen at the hardware level on sort of, specific nodes to make sure that extends all the way down to the chip level, not just in software?
Yeah, that's a great question, and that's exactly what you're doing, right? You're kind of disintermediating all the different software layers and only trusting, as we said before, the code and the data that needs to be protected, and the actual hardware, right? The CPU, right? In this case, and trusted execution environments, they come in different flavors, right? The one Vikas mentioned, right? SGX or software guard extensions focuses on a finer grained capability, right? To be able to protect only that code and data that you're interested in. There are other trusted execution environments that protect larger blocks of code and data, let's say, right? But with SGX, right, the focus is on that fine grained capability and being able to scale that up to larger pieces of software, larger environments, right? But it comes down to fundamentally having to trust the hardware, right? And ideally nothing else, right, except for your code, right? The code that you want protected in the data. For that, right, you need those attestation statements that Vikas mentioned, these signed statements that actually come from the hardware to say, hey, this is what you're running, right? I've measured it. I, the hardware, the CPU, have measured your code. I've taken the fingerprint of it, if you will, right? And I've signed a statement to that effect, right? And that statement can be linked back through public key crypto, right, and certificates. For an end user to actually verify, right, that this message, right, this statement of what's running on that platform actually comes from a valid, in this case, an Intel CPU that's configured appropriately with all the right version numbers of firmware, et cetera, right, so that you can verify that, okay, I know now that that my code and data is as secure as this trusted execution environment. I don't have to rely on the hypervisor, on the operating system, on other applications, or on the administrator, right? I only have to rely on these two things, right? My code and data and the hardware.
Yeah. And, and we may be getting into a little more technical depth here, but, cloud tends to have somewhat of an ephemeral nature to it, whether something just goes away because that's the way it was priced and purchased. It's ephemeral, or it could be the application goes away. Are there capabilities now that are sort of more cloud aware that say, hey, if that underlying compute resource, however it was delivered, went away, I don't have to do a bunch of manual things? Or are we still kind of in a stage where, if it kind of goes away, there's a manual step to make sure we get back to that completely trusted state?
So developers can leverage a bunch of services. For example, they can kind of store their keys, as an example, like with cloud sealing capabilities, right? So now your keys are saved somewhere else. So when you are, let's say an unplanned event happens and your VM gets taken down, whatever, right? A disk might go bad, or things happen in the cloud, right? So customers should be able to make sure that they are able to resume their environment as they were, if you may, so that they don't see a drop in their current operations, right? So this is something that we are actively working on to kind of bring to developers. And we also have a bunch of workloads that are running in production right now that are, customers are using to drive some really innovative sort of use cases that we can touch upon later in this, what sort of use cases we are seeing here. But in many ways, what we think about it as like, this is sort of meant for customers to run their production workloads at scale, right? Which is sort of what we're seeing with customers doing this already. Mm-hmm. It's more around like, how we are reducing the friction, if you may, to bring your workloads to confidential. For example, we've got 2 models of development here that customers can, get onto confidential computing today. So first is, they can just use like sort of a bespoke model where, they trust only their exact line of code that's running inside that enclave or that trusted execution environment or that, box that we talked about. So you own and every line of code that's running inside the enclave. The other use cases that we've seen pop up, and we are seeing a lot of interest from developers, is this concept of confidential containers, right? So as we know, a bunch of these workloads today are becoming containerized, right? And what we've worked with our open source ecosystem and our ISV ecosystem is we are enabling these containers to, be almost wrapped with a wrapper, if you may. And now your container can run unmodified inside that enclave without you really doing anything. So there is no developer impact, if you may. It's a DevOps impact where there's an additional step in your deployment pipeline that you now have to add this sort of wrapper around your container. But now the advantage is your code did not change at all, right? But now your entire container is isolated, with the guarantees that we mentioned earlier. And now what you have is sort of a confidential container, right? So which is a huge sort of paradigm shift again to the container developer, where now workloads become a lot more secure and honestly confidential when it's running inside the enclave.
Interesting. Yeah, I know that Azure has had sort of confidential VMs in the past. Confidential containers just recently got announced. If somebody comes to you and says, "Hey, what part of the stack should I be making confidential?" Are you trying to get to a point where it's sort of normalized, where you can say it doesn't matter if you feel comfortable with VMs, do it at the VM layer. If you're more focused around the container, do it at the container layer, or like are there some trade-offs, or are there some kind of architectural thoughts between where in the stack you want to kind of initiate that confidentiality?
I think that's a really good question, Brian, because I tend to think about it as, and we've been talking to a lot of customers, right? So this is what we've learned after talking to customers. Is customers are on this trust spectrum, right? It's a spectrum, right? So if you are, running your most sort of private and security sensitive workloads, right? Like, think about it as, like for example, we've seen regulated industries resonate a ton with this capability today, right? So we have financial, healthcare, and government as the three sort of regulated industries that we're working with a ton. So if you are, if you're super sensitive of the line of code that's running inside your enclave, I would say, here's an SDK. We have the Open Enclave SDK that's in the Confidential Computing Consortium, right? Which is a consortium that Intel and Microsoft were the founding members of. So you could use the Open Enclave SDK, or you could use the Intel SGX SDK, or the other SDKs available to write your code in a way where you can run that code inside the enclave. But if you are a customer who has built their application in a way where it is now built, it is containerized, you don't want to touch it, because of a variety of reasons, right? You don't want to touch it.
Sure.
But you want the entire container to be confidential. So in that case, we recommend customers to use one of our SGX wrappers, if you may, to now run that container confidentially inside their enclave. But the uber point that I want to make here is it really depends on where you are on the trust spectrum. If you want complete control over every line of code, leverage one of the SDKs we have. If you want, like, for example, your containers to just lift and shift and run inside the enclave, you can do that. Over time, we do expect that this sort of capability becomes ubiquitous, where as the world moves from like HTTP to HTTPS, right, we do expect the world to move from computing in the clear to computing confidentially. It's sort of the ramp that we see to kind of get there.
Yeah, no, makes sense. And we'll get, for those of you who want to dig more into it, we'll get links to those SDKs and the standards that are being put together for it. We'll get those in the show notes. I know both of you get a chance to talk to a lot of companies about this. Obviously, as you're building the technologies, as you're working with consortiums, do you find, I'll start with you, Ron, like, do you find that, there's a certain type of application? Is it, is this more applicable sort of to new applications because you don't have to redo things to get them into a confidential state? Or do you find, the technology's there to take both existing applications and new applications and make them, such that they can be, they can be confidential, they can be protected properly? Is there a trend one way or the other, or what do you see out there?
No, excellent question. It really is both, right? I don't want to kind of cop out on the answer, right? But it's both, and I'll explain why. And it goes back a little bit to that that spectrum that Vikas talked about, right?
Mm-hmm.
You do have a number, and this is the most exciting piece of confidential computing. You do have a number of new, let's call them use cases or usages, right? That were just not possible before, right? If you're in a certain industry that is heavily regulated, either government regulations or professional industry type regulations, that just prevents you from moving sensitive data to a cloud type environment, let's say, right? Or even moving the operations itself, the computation itself to that environment, right? You couldn't benefit, right, from the efficiencies and the scale, right, that cloud brings, right? Or if you had use cases where you're doing machine learning over some data set, private data set of your own, right? But you can get much more fidelity, right, if you could extend that machine learning over broader data sets, right? But the people who own that data also are very sensitive about sharing that data. Both those use cases, right, are supported by confidential computing, where you can now move the sensitive data and computation to a cloud environment and have these higher assurances on the protection of that code and data. And or, right, you can move machine learning type workloads, right, into a cloud environment and have them compute over data sets coming from multiple parties, right, without any of the parties having to share that data. So these are kind of like brand new greenfields, if you will, right? The sort of use cases that are just being built, right? And so this kind of falls into the part of your question when you're asking, is it more new code and new applications, right? Definitely, right? Blockchain is another fine example, right? Where we see a lot of uptake on confidential computing, because all of this code is very new, right? And there's been a huge scramble to look for better, consistency algorithms, right? And how to address some of the power and compute overhead, right, for blockchain. But there are, a broad set of applications, very, very broad, right, of legacy applications that have just existed for a long time. And as Vikas says, a lot of people don't want to have to try to refactor those applications, those workloads. They don't want to have to deal with it at all, right? They would like to benefit from the properties of confidential computing, but they kind of want a one-button solution that says, hey, lift my solution here and place it down into a confidential container and just let it magically, right, get all the properties that confidential computing provides it. And so it's important for all of us as an industry, and that's why we collaborated on forming the Confidential Computing Consortium, right, to ensure that there are tools and SDKs and other capabilities, whether they're commercial or open source, right, which is definitely a big focus on the Confidential Computing Consortium, that those tools are available for people, right? And of course, we're at the early days of that, right? And we have some fantastic tools out there right now, but there's still a lot more to come, I think, right? That are going to be doing wonderful things, right, with confidential computing. We're just starting to scratch the surface, really.
Yeah, no, it makes a ton of sense, and I feel almost funny asking this last question, because we're just now introducing the audience to confidential computing, at least in terms of this show. But they always have an itch to go, okay, but what's it driving? What's coming next? What are some of the things as you're working in the consortiums, as you're talking to early customers, as you're talking to the various technology partners, like maybe beyond blockchain, maybe an industry specific things? What are some of the things that people have now taken these fundamental building blocks and they're starting to do? What are some interesting use cases or stuff that a year ago you were like, I never would have thought that could have happened?
Yeah, that this is something that Ron mentioned. I want to really double click and emphasize that. Like, some of these use cases are not possible before, right? Like the simple use case about I want to share data with somebody else to get a business outcome. And let's take an example with healthcare, right? If I want to do new vaccine development, especially this is pretty valid in the COVID times that we're living in right now, right? If I want to do vaccine development and I have data in my data set as a drug company, and there's another drug company that has that data set as well, but my data set is different than their data set. But if we were able to combine these two data sets together confidentially, where none of these healthcare companies can see each other's data, now we're talking something, right? I can run ML models inside that enclave, which gets me that outcome that previously I was not able to do. So that's one example, which is sort of this multi-party data sharing that we've seen resonate a ton with our customers. Now, there are three verticals that I mentioned earlier. I'm going to go in a little bit. in the financial, healthcare, and government verticals. So in the financial verticals, we've seen scenarios around fraud protection, transaction processing, customer analytics. This is something we're working with a couple of customers on. In the healthcare side, we've seen use cases around disease diagnostics, insurance fraud protection, even like contact tracing, right? Like we need to be able to trace our contacts in these COVID times, but do it confidentially. And the other big bucket that we're seeing a bunch of use cases arise are in the government space, where we want to, build critical infrastructure, as an example. Things that we want to do with cyber crime prevention, where multiple government entities, even inside that same country or even a state, if you may, like today, these different organizations inside a state cannot share data with each other. But what if they could share data with each other and really drive that business outcome that they're looking for? So similarly, records and evidence management, intelligence analysis. There are so many use cases that we are seeing coming up, which were previously super hard to do. But now, because of these capabilities that we're providing, they now get unblocked, and so much can be now done, which lifts our entire industry up to make these use cases possible.
Yeah, no, it's fascinating. I know, for myself, a decade or so ago, I was working on some stuff that, would fall into that category of, there are very difficult ways to share things. And, the number of hoops you had to go through, and it ultimately just became, and those types of collaborations just took a really long time. You never got the outputs you wanted because you had so many hoops you had to jump through to kind of partially share stuff. So just to hear that, people are going to be able to solve problems that involve collaboration, involve, sharing information you couldn't do before, that now, still generally, keeps those same boundaries in place, but now allows that collaboration to happen. It's exciting, right? And it could be you're solving a global problem, you're solving a new partnership problem, you're sharing data. It's exciting to see all those things happening. Gentlemen, I want to be conscious of everybody's time. I thank you so much for helping us kind of dive into this. It's a new topic for us. I know it's an emerging technology topic. I want to give you one last sort of shout out in terms of if people are interested. Obviously, they can follow up with you. We'll get things like your Twitter handle and other things in the show notes. What maybe are the best ways for folks to kind of get started with this? What's an easy way to go learn about it, to validate it, to see if it makes sense for them?
So the first thing I would recommend is, we have a simple URL, aka.ms/AzureCC, Azure Confidential Computing, Azure CC, aka.ms/AzureCC, that you can use to kind of get started. And also Ron can probably talk about a couple of Intel websites that have recently gone up. Ron, do you want to talk to those?
Yes, so certainly Intel has had a web presence, right, around software guard extensions for some time, and there's probably well over 200 independent research papers out there too, right, coming from academia and elsewhere, right, and some of our websites, and I'll get you those to you for the notes, right. Kind of catalog a lot of that interesting research, right? A lot of it coming from Microsoft research as well, right? But I would also point everybody to the confidentialcomputing.io website, right? Which is the website for that confidential computing consortium that we talked about, right? And if you really want to get involved, right, there are a number of projects being sponsored by that confidential computing consortium, which kind of falls under the Linux Foundation, right? That just anybody can get involved in, right? And we're seeing a lot of traction there too.
Yes, thanks for catching that, Ron. Actually, I would love for folks to check out our Confidential Computing Consortium website, where we have partners, customers, everybody collaborating with each other in the open.
Yeah, no, and that's great. And open source is always a really good facilitator of new ideas and getting people to think about things in new ways and to collaborate in new ways. So Vikas and Ron, thank you so much for the time again today. We really appreciate it. We enjoyed the conversation. Folks, I'm going to wrap it up with that for myself and for Aaron. As always, thank you for listening. Thanks for telling a friend about the show, helping us spread the community. Thank you for giving us feedback on iTunes and the other places you listen to the show. And with that, we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.